Hello, welcome to our stats notes section 3.1. So we're starting chapter 3 now. We're going to start off with measures of center. So here we're going to get into calculating some statistics. So we're going to take our data and we're going to calculate things from that data. One of the important things to measure with data is what's called the center. You can think of the center as kind of the average or the typical. So if someone has a set of data, what do they kind of expect to see? What's the most common, kind of value for that set of data? If you're looking at like incomes for a city, your average income, your middle income, that most common, the value you're going to see a lot of, that's going to be the center. You're looking at the middle. We don't want the really high or really low values. We kind of want to see something that's representative of the whole set. Now, there's actually lots of different ways to measure center or measure what's average. We're going to go over four of them here for this section that we kind of see more often. First one is probably what most people think of when they think of average or the measure center is the mean. In fact, when people talk about average, that's usually what they're talking about, is the mean. So the average is the mean. And this is when you just add up all the values and divide by how many there are. So you have 20 values, you'd add up those 20 numbers and then divide by 20, and that gives you the mean. So mean is a really common way to measure center. Probably what you think when you think of average. That is the mean. The next one is called the median. So the median is a different way to do it. The median, we look for the middle number. But the middle number, of course, only makes sense if the data is in order. I used to teach, middle school for a while, and middle schools would be terrible about I give them a set of numbers and ask them for the median, and they wouldn't put the data in order. So they'd have like the largest number would be in the middle of the set, and they'd say, oh yeah, the largest number 25, that's the median. And say, well, that's the biggest number in your data set. That's not the middle. That's the highest number. You have to put it in order to get the right middle value. So median needs to be in order for median to make sense. Now it is possible for you to have an even data set. So you have an even set of numbers. So you might have 10 values. Then there's no specific middle number. Because if you have an even data set, you have 5 on each side, there's nothing left for the middle out of that 10. So if you do have an even data set, you're going to take the two numbers that are in the middle, so the two most middle numbers, and you'll find the mean of those two. Basically, just find the average of those two in the middle. And that will give you your number that you'll use for median. So maybe 4 and 6 were the two middle numbers, and the average is up, and you get 5. That would be your median for that set, even though 5 wasn't part of that data set. 4 and 6 were. Median, again, it's the middle. If you ever have an even data set, you have to average the two middle numbers. Mode is the third one. Mode. This is just whatever's the most common. So what's going to happen the most often. We saw that in the previous section. We were doing chapter 2, section 2.2 and 2.3. We talked about modality and stuff. We looked at those graphs. I said how that's like the peak where there's the most of that value. That's what mode is. The mode is where you get the most of the same number over and over again. So if I have 20 data values in my data set, and the number 7 shows up 5 times, and that's way more than the rest of them. That'd be my mode. So mode is just the one that's the most common. It occurs the most times. Now it is possible to not have a mode. So if every single number in the data set shows up once, well, there's not going to be a mode, right? So if all the values occur once, there is no mode. All values once, no mode. And that's totally possible. That can happen. Now, when you get a big enough set of data, it's very unlikely. You're usually going to have at least something that shows up more than once. With small data sets, it's definitely possible to have no mode. And then it's also possible to have more than one mode. We saw that with modality, right? We saw bimodal and multimodal. So you can have things that actually both show up. When we're doing these calculations, we're going to have to here we're going to say it's all the stuff that shows up the same number of times and the most number of times. That would be your multiple modes. We saw with the graphs, you can kind of blur that a little bit and say they don't have to be the same height. But if we're doing the calculations for mode, for like the homework and the tests and stuff, in that situation, you want to look for something that occurs equally number of times. So I mentioned that like set where 5 7s showed up, maybe you had 5 12s showed up. If they both showed up 5 times, you could have 2 modes. You could have 7 and 12 be modes. So again, if more than one occurs the most times, then they're all modes. So you can have 2, 3, 4, 5 modes, depends on the data set. Mode is one of those things that doesn't make a lot of sense when you're working on small data sets. You have 10, 15, 20 numbers. Mode is just going to be whatever random number shows up a couple times. in really big sets of data, when you go out and do real statistics, mode is actually a really good measure because you have enough values. You have thousands or hundreds of thousands of values. Then mode is going to be pretty practical because whatever shows up the most, that is going to be the most common. That's going to show up over and over and over again in those thousands or hundred thousands of times. Last one we have here is called the mid-range. This one's not as commonly used, which we'll talk about as we go. Why? The mid-range just takes the average of the maximum minimum value. So it ignores all the other values. It just takes the max value, the largest, the minimum, and finds the average of those two. So you really just need the top and the bottom, and you can find the mid-range. It's really easy to do. All you have to know is the biggest and the smallest values, and just add them up and divide by 2. But it only uses those 2 values. That's all it uses. So we're going to go ahead and find mean, median, mode, and mid-range for a couple data sets so that we can calculate these. So first off, remember that mean is the average, where you add them all up and divide by how many there are. So I'm going to take my data set and I'm going to throw in my calculator and add them up. So we add up that 85, 71, 60, 54, 85, 97. Get our total here, which in this case we got total is 452. So we have 452. And then divide by how many numbers there are. Well, there's 1, 2, 3, 4, 5, 6 numbers. So just divide by 6. And we get 75.3. My math lab will tell you what to round that to. I got 0.3 repeating, so I just rounded to 0.3. But my lab, the MyStat lab will tell you what to round to. So that'd be my mean. To do median, again, remember median, we have to put them in order. So you can't work with a number set like this. So I first have to just put them in order. So I see 54 is the smallest, and then 60, and then 71. Hopefully I don't make a mistake. This would be fun to make a mistake on the notes I'm making. Hopefully I don't. So we got 54, 60, 71, looks like 285s. Those, and then the 97. And again, median, I'm just looking for the middle number. So I use the grade school cover-up method. You just cover up the ends and cover up the next one. And again, if you get to 2 numbers in the middle, because we had an even set, 6 values, you take those 2, you add them up, divide by 2. So I'm going to take the 71 plus the 85, add them up and divide by 2. You get the number that's halfway between. So you could type it in, 71 plus 85, divide by 2. And you get 78, which is halfway between. You notice if you add 7 to 71, you get 78. You add 7 more, you get to 85. So it is literally halfway between because they're about 14 apart. So right in the middle is 78. So 78 is the median. So we got 75.3 for the mean, 78 for the median. Next one would be the mode. Mode, again, is just what happens the most often. Well, there's 2 85s. So mode is just going to be 85. That's it. You're just looking for the thing that shows up the most often, the most times, and that is your mode. Last one's mid-range. Mid-range, we're just looking at the lowest and the highest values. So we're going to take that 54 and that 97. Those are our, sorry, 97. I write the right number, 97. Take the smallest and that biggest number, add them up, and divide by 2, and that gives us the mid-range. So it just cares about the 54 and the 97. It doesn't care about anything in the middle, just the bottom and the top. So I take 54 plus 97, divide by 2, and 75.5 is the mid-range. And so you can see there's a lot of variation. This is why we have different ways to measure center, because you can get a small value like 75.3 for mean or 75.5 for mid-range, or you might get some big values like 78 for median is a little bit bigger, and 85 for mode is way bigger. So you can see that these all can give you different values. And in real life, when you work with statisticians, if they're professionals and they're doing their job right, they use the one that's most representative for the set. They might avoid using certain numbers because they might not work as well, and they'll use the ones that are good. But in real life, a lot of times we'll also see people who are trying to use statistics to confuse people or to sway people. And in those cases, they'll use the one that reflects what they think, what they believe. So if you're a company trying to sell your product, you're going to use the value that's going to best reflect you, whether it's mean, median, or mode, or mid-range. You're going to pick the one that looks the best. And you'll say it's a proper measure of center. I can call that the average or the middle, the center, but it can be very misleading. So always be wary. Think about that. That there's lots of ways to measure center. I'm going to try another set. So again, to do mean, first thing we'll do is we'll just add up all the numbers. Just add those up real quick. Hopefully I don't miss any numbers because that would really mess this up. Okay, so I got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's something I always do when I'm adding up a set of numbers like this. Make sure you have the same numbers in your calculator as you are on the list, and that way you can double check and make sure you're getting at least all the numbers. Good to just look through them real quick and make sure you didn't miss any digits or anything. So I got 440 divided by, here I have 1, 2, 3, 4, 5, 6, 7, like we just said, so divide by 7, and 62.85, which will round to 62.9. Again, MyLab will tell you how many decimal spots, but we'll round that up for that. To new median again we have to put them in order. So look for the smallest number. Looks like 30 is my smallest. So 30 and 35, we got two of those. 42, there's two of those. 56 and 200. Okay, we put them in order, look for the middle number, and this time when we cover up, use our cover up method, there is a middle number, right? Because there's 7 values now, and since there's 7 of them, an odd number, there will be a number in the middle. That is your median. If there's not an even set, if there's an odd set, the median's pretty easy. It's just literally the middle number. Mode, what's the most often? Well, there's two 35s. So again, if something shows up more than everything else, but there's also two 42s. So actually, both 35 and 42 are both modes. It's possible to have more than one mode. So 35 and 42 are both modes. There's two answers to this one. Because there's two different numbers, they're both modes. Again, they both show up twice in this case, so they're modes. And again, with small sets of data like this, mode doesn't make a lot of sense. Because these just happen to be the numbers that didn't show up twice. Just like 85 up here just happened to be the number that showed up twice. In real life, we have lots and lots of data. Then mode makes more sense, but for these small sets, it's kind of a silly measure. Mid-range again, remember mid-range, we take the top and the bottom, add those up, divide by 2. So we get 200 plus 30, divide that by 2, about 230 gives me 115, I believe. Mid-range. So our mid-range on this one is 115. You can see a big difference here, right? You see how the mean is really high, the median's not so high. Mid-mode is kind of, lower than median even, and then the mid-range is huge, right? It's the biggest number of them all. So again, a lot of variation happens with these. I got one more set, do one more set, and I'll talk about a little bit about the properties of these different types. So again, to do mean, just like before, I'm going to add these numbers up. So I'm going to take these numbers, add them up to get that mean. All right, so we got 232. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So divide by 8. So we get 29 for the mean. Again, to do median, we have to line those. Up in order. So we got a 3, another 3. So 3, 3. Next is 21. It looks like. So I got two 21s. Got a 30 and another 30. Looks like I have two 62s. Again, to do median, we're just looking for the middle number. So we cover up, looking for that middle number. And here we have two numbers in the middle. So again, I'm going to add those up, divide by 2. So 21 plus 30, half divide by 2. Is that 51? Divide by 2, and we get 25.5. That's our median. So that'd be our middle. By median standards of the middle number, it's halfway between those two. Next one, mode, we're just looking for most often. Well, in this case, we have 4 different modes, right? 3 shows up twice, 21 shows up twice, 30 shows up twice, 62 shows up twice. So again, this one, if everything shows up twice, well, they all show up the most often, so they're all modes. So again, mode could be really silly for these small sets. You probably wouldn't see this in real life if you were collecting data. If you saw something with 4 modes, that's probably a bad sign. And again, don't forget, you can have no mode. It's possible that nothing's a mode. You could have a set of data where everything shows up once, nothing repeats, and then there wouldn't even be a mode. All right, last thing, mid-range, we just take the top and the bottom, add those up. So 3 plus 62, divide by 2. So we get 65 divided by 2, which is 32.5. Okay, so that's mean, median, mode, and mid-range. Now you saw that they can vary a lot. There's big differences. We talked about how mode can have more than one, sometimes have none. Now, one of the most important properties of these, one of the most important things to talk about with these is whether or not they are a resistant measure. Now, what is a resistant measure? Well, a resistant measure is a measure of center that's not affected by outliers. So a resistant measure is not greatly affected by outliers. So if you have an outlier, remember we talked about outliers previously. We said outliers are numbers that are really big or really small. They don't really fit with the rest of the data. And so we say if you have an outlier, some of those measures are going to get really messed up because the outliers got to change them a lot. And some are not. Some it's not going to matter at all. So which ones are resistant? Well, first off, the one that's very resistant is median. Median is a really great resistant measure because to find the median, you start out with the covering up and you go to the middle. So you have a number that's really big or a number that's really small. Well, when you go through your cover up, that's just one number that covers up. It doesn't matter if it's huge or medium, but it's just one number that covered up on either end. And so you kind of almost ignore it. Mode is another number that's actually pretty resistant because usually you're not going to have more than one of the really big or small numbers. You know, if it's an outlier, if it's unusual, you're not going to have more than one of it. So mode usually doesn't match outliers. So those two are pretty resistant. Now the ones that are not resistant, well, the big one is mid-range. And that probably makes a lot of sense because if you think about mid-range, it's taking the top and the bottom numbers and just finding the average of those two. All it looks at is the biggest number and the smallest number. And those are the numbers that are most likely going to be the outlier. So if one of those is an outlier, the mid-range is going to be very different. So mid-range is terrible. Mid-range is not used most often, typically, because it is so susceptible to outliers. The only time you'd probably use mid-range again is if like you didn't have any other better calculation you could do, you're stuck working with just the highest and lowest number, or again, you're trying to be deceptive. Like mid-range isn't something you should usually see. It's very not often used. Like people don't really use mid-range. The last one's actually mean. Now mean does get used, but it is actually not resistant. The reason mean is not resistant is because when you add them all up, it includes the outliers. If you have a really big number or a really small number, that gets included as one of those numbers. And so it does get distorted. Now it doesn't get distorted as bad as the mid-range, which is why it's still used. Also, a lot of times people will use mean when they know that there are no outliers or they're not a big deal. So just looking back what we saw before, like we saw that in that middle set, it's a really good example. We had this big number 200. This is definitely an outlier. I'm going to go throwing my pen on the floor. But that guy was an outlier. And because he's an outlier, you can see that the mean and the mid-range were both much bigger than the mode or the median. These ones really reflect the rest of the numbers. See how these are all like 30 to 56, that range there. So 40s make sense for middle. So 35 to 40, that's reasonable. 62 is bigger than all the numbers except for the outlier. 115 is way bigger than all the numbers except for the outlier. So you can see that these ones were distorted by the outlier, whereas median and mode were not. And that's what you'll see. Really big numbers, really small numbers will mess up the mean, they'll mess up the mid-range, but they won't mess up the median and mode. Now you'd think from that we'd spend all our time the rest of the course working with median because it's so resistant. We'll actually spend more time working with mean. Now there are special cases where the median, the mode, the mid-range, and the mean are all going to basically be the same value. That's going to be when you have a nice perfect bell curve or normal distribution. So if you have that nice perfect normal distribution bell curve shape, then these values are all pretty much the same. And then you don't really have to worry about too much when you pick. And that's why a lot of times we'll work with mean because we're going to be working a lot with bell curves. So it doesn't really matter which one we pick. Mean is also a little bit easier to calculate on a calculator or with a program. So I think that's part of why we work with it as well. So you'll see a lot of mean throughout the rest of the semester. Okay, that's probably the important part for the homework. So what we just covered now, you should be able to find mean, median, mode, mid-range, mean. You should know about resistant measures, that kind of thing. Last part here, we're going to talk about some notation, some ways of writing numbers and stuff that we're going to use the rest of the semester. So I want to just make sure these are familiar. You'll see these show up in formulas and stuff throughout the semester. So I just want to make sure you understood. Now in algebra, we use x, y, and z for variables, and then the variable is just a value you don't know that you might have to plug a number into. We kind of think of it as something that could change because we don't know what it is yet, so we're waiting to find out what it is. In stats, we're still going to have kind of our unknowns. We don't know what the number is a lot of times, But we're going to have lots of things because we're going to be going out and collecting data, so we're going to have lots of responses. So we don't just have like one number, we have tons of numbers that we don't know. So instead of using x for the one value, that doesn't really work very well when you have 100 values because there's only 26 letters. It's not going to work very good. Instead, we'll use x to stand for all the numbers we don't know, and then we'll put a little subscript I on it and replace that I with a number to indicate which specific one of those unknowns we're talking about. So x sub I is going to be the unknown we're dealing with, where it's the ith unknown. So if this is x sub 2, it's the second one. If it's x sub 4, it's the fourth one. So it's telling us which data value. So that's what we're going to use. This is pretty common when you're working with data sets. So like say we have a data set right here. We have these 1, 2, 3, 4, 5, 6 numbers in our data set. If I want to talk about x sub 2, I'm talking about the second point in the data set, right? 1, 2, there's the second point. So 12 would be x sub 2. So x sub 4 in this data set, well, 1, 2, 3, 4, it's going to be number 8. It's going to be x sub 4. So we use this little subscript to indicate which one we're talking about. So this whole set are going to be the x's, or the x sub i's, but the specific ones will indicate with a specific number. X sub 6 would be 19 because it's the last one. X sub 1 would be 6 because it's the first one. So we'll use that notation. If I write x sub I, then I'm saying any of the data values because I'm not talking about specific one. Maybe it's a way to refer to all of them. But if I use a specific number, then I'm referring to that specific value, given a list. A lot of times we want to add up all the values. Of course, that makes sense because we did that just to get the mean, right? We said, okay, we find the mean by adding up all the values, and then you can find the mean. So a lot of times we'll sum up all the numbers. Since that's a really common thing to do, we have a notation for it, and we use this Greek letter right here to stand for summing all the values. This is actually the Greek letter sigma. So this is sigma. So if I'm talking later, I'm talking about sigma. I'm talking about this big Greek letter right here. It just means the sum of. You're adding up all the numbers for a data set, or some of the numbers. That's what this sigma tells me to do. We use this all the time in math, where we add up lots of things. Now, when I wanted to talk about adding up a list of data values, a lot of times we'll write it like this: sigma with x sub I. So x sub I stands for all the data values because we left that I a variable, so we can change, say, 1, 2, 3, 4, 5, 6, and we're saying we're adding up all those things. So a lot of times we'll write it like this. Sometimes someone will be more brief. They want to write as much. They'll have a reason. They don't want to write this whole thing, so they might just write sum of x by doing sigma with an x. And it still means the same thing. It's just kind of a briefer way to do it, so we're not writing as much. Sometimes people want to be more explicit. They want to make sure everybody knows exactly what they're adding up. So they might write it like this one. And so here they're actually writing the x sub I, just like before. They're also adding up this. And this is saying I starts at 1, go up to n, where n is how many data values I have. So like in this case, you have 6 of them. This would be saying add up numbers 1 through 6. 1 through 6. This would just be a fancy way of writing that. But for our intents purposes and stuff, all three of these are just ways to say, add up the numbers in the data set. So you'll see those for that. So one example of this is we're finding the sample mean, or the average. The mean is the average. So we write the sample mean using this symbol right here. This is the symbol for the sample mean. So it's the average of a sample. It's not the whole population, it's just a sample. So a lot of times we'll do that. We'll calculate the mean of a sample. So we'll call that the sample mean. And the formula for it is to sum all the x sub i's and divide it by n, where n is the number of data values. So this is a formula using that sigma notation, right? So we're using that sigma that says add them all up. X sub I stands for the data values, and n just says how many numbers there are. We'll use these symbols a lot in this class. So just to point out, again, x bar like that. We'll call that x bar. That's how you say that. That's x bar. That is the mean of the sample. So if you took a sample of values, you found the mean. That's x bar. When we're using this calculation, we're using sigma for the sum. We're using x as the variable. That's the thing we're represented with the data values. That's your data values. So like if you go out and you collect data about the heights of boys in your sophomore gym class, then this x would be all those heights. It's the results from that study. That's your individual data values. Again, lowercase n like this is going to be the number of data values. We use this specifically though with samples. So when you're working with samples, n is going to be lowercase and it's going to stand for your samples. Now we do have a couple things on here I want to mention to deal with populations, not samples. Remember, a sample is just a part of a population. If you're dealing with a population, not just a sample, then instead of using lowercase n, we use uppercase n, because that's everybody, so it's a big deal, so we make it capital N. So you see a capital N, that's the number of values in the entire population. Now, most of the time we don't know capital N, because we don't usually know exactly how many people are in these big populations. Like the population of the US, it's really hard to measure. The census gets a good guess, but they never get it perfect. So this is a number we don't know, and it changes. As soon as the census is over, people move into the country, people move out, people are born, people die. So it changes all the time. So it's hard to know capital N's, but if you do, that's the number of data values in the entire population. Also, you'll see this little Greek letter right here. This is called mu. This is mu. We'll see mu a bunch throughout the rest of the semester. Mu is just the population's mean. So instead of talking about the mean of a sample, the average of a sample, mu is the average or the mean for the entire population. Again, this is something we won't know most of the time because it's hard to find the average for an entire population. A lot of times we'll actually be trying to estimate what that is. What is the average for the whole group? And usually we'll use our sample data, our sample mean, and try and use that as a guess. So we'll go out, we'll do a study, we'll say, hey, the average height of the sophomore boys in my class was 5'2", and then we'll take that average we got from our sample, and we'll kind of say, okay, well, we think the overall population's average is going to be close to 5'2", and we'll use math to prove that we are right and show that our stats are good and stuff. But that's what we do. So we use sample means like this to try and get an idea about what the population mean is. And that's usually what we're working with. Okay, so population versus sample. Sample mean is just your sample average. It's the average of the sample. Population mean is the average for the entire population. Just because I take a little sample and measure that doesn't mean I know for sure what the population is. So that's why we have two different values, because once we know one, we can kind of make a guess about the other, but we don't know what it is for sure. Okay, so that's what this section is all about. This section is just about, kind of getting used to some of this phrasing, this notation, making sure you know about mean, median, mid-range, and mode, and then, that those are all measures of center. So that's the whole homework for 3.1. It's just going to be dealing with these measures of center and some of their properties and all that. So I'll let you go, and we'll see you on the next one.